If you're a CTO, you know your job isn't just about making systems that work. It's about building systems that last. So today we're going to talk about moving away from those brittle, fragile automations that always seem to break at 2 a.m. We're going to dig into how you can actually architect robust, engineered systems you can bet your job on. Let's get into it.
This quote, man, it just hits the nail on the head, doesn't it? It comes from automation architect Alfaz Mahmud Rizve, and it really gets to the core of the problem. See, when you build a workflow without a solid plan, you're not really engineering anything. You're just kind of crossing your fingers. And let's be honest, in our world, hope is a terrible strategy.
So, let's start by putting a name to that monster that so many of us have had to fight. Or, hey, maybe we even created it ourselves back in the day.
Oh, you've seen this. I know you have. Some eager person on the team gets their hands on a powerful no-code tool and just builds this massive, winding, undocumented chain of events. And sure, it works for a bit, but when it breaks, and it always breaks, it's this tangled mess, a literal plate of digital spaghetti. And this isn't just a tech headache, right? This is a serious operational risk that can ripple out across the entire company.
So how do we fix this? Well, the answer isn't just about finding a better tool. It's about a complete shift in how we think. We've got to stop focusing on the apps themselves and start focusing on the data.
Let's think about this for a second. Imagine you've built your entire lead workflow around, say, the very specific way MailChimp works. What happens in 6 months when marketing decides they're switching to a new platform? Well, you've got to tear it all down and start over from scratch. That's a huge, expensive pile of technical debt you just created.
And here you can really see the difference between these two mindsets. Tool-centric thinking? It's fragile, it's expensive, it's a trap. But when you adopt a data-centric approach, you separate your core business logic from the software you're using. You focus on the data itself, what it is, how it needs to change, where it needs to end up. The tools? They become interchangeable commodities. You want to swap out your CRM? Fine. You change one single connection point and the rest of your logic engine stays exactly the same. That's not just better tech, that's a real strategic advantage.
So, okay, how do we actually build one of these data-centric engines?
The answer is a really simple but incredibly powerful framework. Think of these as the fundamental laws for building any back-end system.
So, what's this grand blueprint for building systems that don't crash? It's called the IPOE Framework. That stands for inputs, processing, outputs, and, the one we'll really dive into, error paths. Seriously, from now on, these 4 things should be the bedrock of every single workflow you or your team builds.
Let's just quickly run through the first 3. First, you've got inputs. This is your system's front door. It is absolutely essential that you validate every piece of data right here, because if you let garbage in, you're going to get chaos out. It's that simple. Next is processing. This is the brain of the operation. Here, you want to process data in batches, not one by one. This helps you respect API limits and keeps you from accidentally DDoSing your own systems. And finally, outputs. This is where the action happens. Here, you use smart moves like upserting, which just means update a record if you find it or insert a new one if you don't. This gives you something called idempotency, which is a fancy word that's key to making sure that if you get the same data twice, you don't create duplicates and corrupt your database.
Okay, now let's get to the most important part for any CTO who actually wants to sleep at night. This is what separates a pretty good system from a truly unbreakable one: how you handle errors.
And here we are, back at our main theme. You cannot just hope for the best. You have to engineer your systems with the absolute expectation that they will fail. Because APIs will go down, access keys will expire, data will show up in a weird format. It's not a question of if, it is always a question of when.
This is the scenario that is pure nightmare fuel for any tech leader. An API connection breaks and your workflow starts to fail. But because you don't have any monitoring, nobody has a clue. Leads haven't synced for 3 days, you're losing money, and you only find out when the furious head of sales is standing in your doorway. This is what we call a silent failure.
Let's be perfectly clear about what this means. A silent failure is an error that your system keeps to itself. It's a slow, quiet data bleed that can go on for days, maybe even weeks, causing catastrophic damage to your business operations and your data integrity. For a CTO, it's pretty much the worst-case scenario.
So, how do we build this watchtower to prevent that? It all starts with designing dedicated error paths from the get-go.
You can use something called a global error trigger, which basically acts like a safety net for your entire server, catching any crash from any workflow. But just catching the error isn't enough. You have to have a rock-solid alerting mechanism.
And this right here is the solution in action. The second a workflow fails, that global error trigger fires off. It immediately grabs all the important data about the crash, wraps it up in a clear, easy-to-read message, and pings a critical Slack channel, something like #OpsCritical. Just like that, a potential disaster becomes a manageable ticket for your team, often before anyone outside of engineering even knows something went wrong.
And all of this brings us to the real takeaway here. This is about a fundamental shift in your role, from being a reactive firefighter to a proactive architect. This is your new mandate. Stop just dragging and dropping nodes and hoping it all holds together. Start applying real architectural principles, like IPO, to build systems that are modular, data-centric, and truly, genuinely resilient.
So, I'll leave you with this one question to think about. Take a good, hard look at your own infrastructure. Are your most critical workflows built on a solid, engineered foundation? Do you have that watchtower that's going to scream the second something goes wrong? Or are they a fragile house of cards, just one little API change away from a silent failure? Are you truly engineering for stability, or are you just hoping for the best?